No, sir.
No, sir.
Put the heading experimental observation of redox reaction. To understand this topic, I will take example of this. Let's say there is a solution in a beaker, and that solution is containing copper sulfate. So this beaker has copper sulfate in an aqueous state, and a Zn strip is dipped in this solution. A Zn strip is dipped in a copper sulfate solution. Now the copper sulfate solution in an aqueous state has copper ion and sulfate ion. There are copper ions and sulfate ions in the copper sulfate solution. In this solution, Zn strip is dipped. Zn is more active than copper. In a metal, Zn is more active than copper. Zn can displace the copper ion. So what will happen in this beaker? The Zn atom of Zn strip, they will go into Zn2 plus aqueous in the solution, and they lose electron. There will be loss of electron, and the Zn atoms from the Zn strip will go into solution in the form of Zn ion. The copper ion which are present in will gain electron and deposit as a copper solid on the strip. Copper ion gain electron and deposit as a copper solid on the strip. So this particular part, the Zn, is a oxidation, and this part is a reduction. The oxidation of Zn takes place here, and the reduction of copper ion takes place here, as Zn has lost electron and copper ion has gained electron. If we want to write overall redox reaction, we can write down the overall reaction by cancelling the electron. So these electrons that can be cancelled, we can cut this electron and we can write overall reaction. So after addition, what would be our overall reaction? Zn solid reacts with the copper ion, that gives copper solid and Zn ion. That is our overall reaction. Zn has displaced the copper ion from the solution, and Zn has gone into Zn2 plus ion. So this reaction is redox reaction. That is redox. It has oxidation half as well as it has reduction half. Both the half are there. So this is our overall redox reaction. This is our oxidation half and this is our reduction half. Now what would be experimental observation in this setup? When the reaction will proceed, what you will notice? The copper sulfate ion, the aqueous copper sulfate solution, that is of blue color. And with the time, the copper ion will deposit as a copper solid. So you will notice with the time as the reaction proceeds, the blue color of copper sulfate will fade. It will fade, right? So the blue color, the intensity of blue color decreases with the time, and once all the copper ion will deposit, it becomes colorless. If all the copper ion deposit, it becomes colorless, right? What other observation you will notice? The copper ion gain electron and deposit as a copper on the Zn strip. So this part of the Zn strip where the copper deposit, you will see the change in a color in this part. So it becomes like slightly reddish of color because of the deposition of copper. So these two are the experimental observation of this redox reaction, right? And from this you can conclude, yes, a redox reaction is going on. Displacement of copper ion by zinc is going on. And this is how experimentally you can study the redox reaction. And you can note down the observation. Observation is intensity of blue color decreases with the time. And because of the deposition of copper on the Zn strip, Zn strip it will become reddish of color. That is what the practical observation. So is this clear? Is this topic clear to everybody? I hope you have noted this. Ask any doubt if you have. Okay. Then you write question based on this. Write down one question based on this. The question is, copper is more reactive than silver. Copper is more reactive than silver. So the copper can displace silver ion. So the copper can displace silver ion. If the copper strip is dipped in a silver nitrate solution, if the copper strip is dipped in an aqueous silver nitrate solution, if the copper strip is dipped in silver nitrate solution, if the copper strip is dipped in an aqueous silver nitrate solution, write down the first question. Write oxidation, comma, reduction, and overall redox reaction. Write oxidation, comma, reduction, and overall redox reaction. That is the question number 1. Question number 2. Give experimental observation. Give experimental observation of redox. Give experimental observation of redox. All right, solve these two questions, and if you have any doubt in solving these two questions, ask me before I move to next topic. Let me know if you want me to solve on the board.
So what would be the experimental observation?
Experimental observation is any color change in the solution or deposition on the strip, and because of the deposition, the color of the strip changes.
But what would be the color change?
I think
What
blue
should we
will
write?
It will become blue.
It will become bluer, right?
Correct. It will become blue because the copper atom will come into the solution as a copper ion.
And white or silver deposits on the strip.
Yes. There will be silver
Okay.
deposition on the strip. So that part of the strip will become silver in color.
So the color should be silver only, not white.
On the strip.
On the strip. And in the solution, it goes from colorless to blue.
Blue.
Should I do on the board?
It's fine.
Yes, sir.
Right. See, what will happen to copper atoms? It will go into the solution as a copper ion. And there will be loss of 2 electrons. Copper has changed from 0 to +2. So it loses 2 electrons. And this is oxidation. That is oxidation. So there is oxidation of copper. What happens to silver ion? In AgNO3 there are 2 ions. Ag plus is there and
NO3 minus.
NO3 minus is there. So what will happen to silver ion? Silver ion from the solution gain electron and deposit as a Ag solid. So this is
Wouldn't it be 2 Ag plus 2
this
electron
balance-
minus gives 2 Ag?
balancing for 2 electrons. As there is a loss of 2 electron, as we are going to write overall reaction, we can balance the electron. Number of electrons that keep both in both the equation. This can be multiplied by 2. So write down 2 Ag plus 2 electron and the 2 Ag for that. And this particular half is reduction half. So there is an oxidation half, there is a reduction half. And then there is an overall redox reaction. Then you can write down the redox reaction by cancelling the electron. Cancel these electrons. And this is our
Cu plus 2 Ag plus gives
plus gives
Cu2 plus
Mu2 plus
Ag.
2Ag.
2
Redox reaction. Now you can write down your experimental observation. Solution changes from colorless to blue and copper strip has a deposition of silver. That is what the observation. Are you all clear in this topic?
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
So I'm removing this. Now I'm going to third definition. Oxidation number. Using oxidation number, how to identify reduction half and oxidation half. As I already explained you, during reduction, I'm writing it once again. During reduction, what happens to oxidation number? Oxidation number decreases. And during oxidation, what happens to oxidation number? It increases. So that is what the definition, that in reduction oxidation number decreases, in the oxidation number increases. Now to understand this definitions has no limitation. That can be applied on any redox reaction. So to understand this, I have to begin with the oxidation number, how to find oxidation number. So write down rules to calculate oxidation number. Now we are going to understand rules to calculate oxidation number. In that, write down first rule. First rule, oxidation number of any atom in its elemental state is 0. The oxidation number of any atom in its elemental state is 0. That is rule number 1. Oxidation number of an atom in its elemental state is 0. Now, what do you mean by elemental state of an atom? Suppose if I ask what is the elemental state of hydrogen, then what is elemental state of
Zero.
hydrogen is H.
Zero.
That is the elemental state of hydrogen. So in any chemical reaction, if you see hydrogen, reactant side or product side, and if you see hydrogen in the elemental state, take oxidation number 0 in the elemental state. What is the elemental state of oxygen?
O2.
O2. Oxygen elemental state,
O2G.
O2 gaseous state. Sodium is Na solid.
And
Phosphorus is a P4 solid. Sulfur is a S8 solid. This all are the manganese is a Mn solid. Metal there in the solid state. This all are elemental form. And whenever you see atom in the elemental form, take its oxidation number 0. That is rule number 1. Have you noted?
Yes.
Then write rule number 2. In the rule number 2, if you see any atom with the charge, in the equation, if you see any atom with the charge, single atom with the charge, I am not saying multi-atom with the charge. I am not talking about polyatomic ion, monatomic ion, which has a single atom and the charge, like Na plus, Cl minus, Al3 plus, these all are a single atom with the charge. So whenever you see in the equation any single atom with the charge, remember charge is the oxidation number. So like in Na plus, the oxidation number is +1. In Cl minus, the oxidation number is -1. In Al3 plus, it is +3. If it is like O2 minus, then it is -2. Like this. So that is rule number 2. Whenever you see any single atom with the charge, remember charge is the oxidation number. Rule number 3. Then write down the rule number 3. The sum of oxidation number of all the atoms. The sum of oxidation number of
in a
all
compound
atoms,
is 0.
that equals to whatever charge on the molecule. If there is no charge on the molecule, if the molecule is a neutral, it is 0. And if there is a charge on the molecule is equal to whatever the charge. So the sum of oxidation number of all atoms is equal to whatever charge on the molecule, and 0 in case of neutral. 0 in case of neutral. Let me give you one example. See the KMnO4. There is no charge on the KMnO4. This molecule is a neutral. So as per this rule, the sum of oxidation number of potassium plus oxidation number of Mn plus 4 into oxidation number of oxygen, that equals to 0.
0.
0 because the molecule is neutral. There is no charge on the molecule. Then the sum would be 0 in that case. Sum of oxidation number of all the atoms, that equals to 0. If there is a charge like this, it is a dichromate ion. This ion is called dichromate ion. Then 2 Cr plus 7 oxygen, that equals to -2. Then whatever the charge. The sum equals to whatever the charge. If there is a positive charge like NH4 plus, it is ammonium ion. Then oxidation number of nitrogen plus 4 into oxidation number of hydrogen, that equals to plus 1. That is rule number 3. The sum of oxidation number of all atoms, that equal to whatever charge on the molecule, and 0 in case of the neutral. So I hope you have noted rule 3. Then write down rule 4. Rule 4. The oxidation number of alkali metals. Alkali metals is the group 1. That is always plus 1. The oxidation number of alkali metal, that is group 1, is to be taken plus 1 always. No exception for alkali metals. The oxidation number of alkaline earth metal. What are alkaline earth metals? Group 2.
Group 2.
Group 2.
That is to be taken always plus 2, no exception. Alkali metal is a lithium, sodium, potassium. This is a beryllium,
Magnesium, calcium.
calcium. So whenever you see alkali metal in any equation, always take plus 1. And whenever you see alkaline earth metal, always take plus 2.
Plus 2.
They do not have any other oxidation number. They always remain same. That is rule number 4. Now rule number 5. Write down rule number 5. This is called rule of oxygen. This rule is called rule of oxygen. The common oxidation state of oxygen is -2. The common is -2. Oxygen is found in a -2 state in most of its compound. There is an exception for oxygen. Now what are the exception? Write down exception. The exception is whenever you see oxygen in the peroxide, like H2O2 is a hydrogen peroxide, Na2O2 is a sodium peroxide. In peroxide is -1. It is -1 in the peroxide. And when oxygen combined with the fluorine, let's say in the OF2, remember fluorine is always -1. Fluorine is most electronegative element. So it is always -1. No exception for the fluorine. So there is no exception for alkali metal. There is no exception for alkaline earth metal, and there is no exception for fluorine. These three do not change.
For doubt.
Yes.
So in OF2, the charge of O is
Now let's calculate oxygen in OF2. To calculate, I will apply.
+2.
To calculate, we will apply that rule of summation. It is oxygen plus 2 into fluorine. There is no charge, so 0. The total is 0. Now, as I said, fluorine doesn't change. Fluorine always remain -1. There is no exception for fluorine, no exception for alkali metal, no exception for alkaline earth metal. Alkali metal always remain +1, alkaline earth metal always remain +2, and fluorine always remain -1. So apply this. O plus 2 -1, 0, then oxygen you will find in a positive oxidation number. Is your doubt clear?
Okay, yeah, thank you.
So these are the exception for oxygen. Otherwise, apart from this, oxygen you should take -2. In most of the compound, oxygen is -2. So that is the rule of oxygen. I am removing this. Then you write down the rule of hydrogen. next rule is the rule of hydrogen. Now, what is the rule of hydrogen? Hydrogen common oxidation state is +1. In most of the compound, hydrogen is found in a +1 state. There are exceptions for hydrogen. Now, what are exceptions for hydrogen? Whenever hydrogen form compound with the first group and second group, first group, second group hydride, like sodium hydride or calcium hydride, these are the hydride with the first group and second group, the hydrogen is in the -1 state. Because you know, sodium always remain +1. It doesn't change. Sodium is alkali metal. So it is a Na plus H equal to 0. This is +1. So H is -1.
-1.
So that is the exception for hydrogen when hydrogen combined with the first and second group hydride. Otherwise, hydrogen you should take +1 in most of its compound.
Okay.
After this, you write down the rule of halogen. Now, what is the rule of halogen? The halogens are fluorine, chlorine, bromine, and iodine. These are the halogens. Halogen common oxidation state is -1. The common oxidation state of halogen is -1. Fluorine always -1. No exception. Fluorine always -1. No exception for the fluorine. There can be exception for other halogen. Like I'm giving you one example. These halogens are less electronegative than oxygen. Chlorine, bromine, and iodine, they are less electronegative than oxygen. So whenever they combine with the oxygen, they are found in a positive oxidation state. Fluorine is more electronegative than oxygen. I am giving you one example. See the compound ClO3 minus. The ClO3 minus is called chlorate ion. That is chlorate ion. In ClO3 minus, as oxygen is more electronegative than chlorine, let's calculate Cl plus 3O is equal to -1. Now here oxygen that is in a -2 state because it is more electronegative than chlorine. So Cl plus 3 minus 2 is equal to 0. Cl that is equal to Cl -6. -6 will go other side. The Cl you will see this is -1. So Cl you will find in a +5 state. Chlorine here you will find in a positive state. So when other halogen other than the fluorine, they combine with the oxygen, they are found in a positive oxidation state. As well as when halogen they react with each other, that is called interhalogen compound. Example ICl3.
Iodide fluoride.
Iodine trichloride. It is an interhalogen compound. In interhalogen compound, the less electronegative halogen is found in a positive state. Here, iodine plus 3 chlorine, that is equal to 0. Chlorine we will take -1 as it is more electronegative. So iodine is in the positive state. All right. So that is a rule for halogen. So this were the rule for to calculate.
Sir, what is the name of this compound?
Hello, sir.
Yes.
What is the name of this compound?
This compound is known as chlorate ion.
No, the ICl3.
ICl3 is the iodine trichloride.
No, you mentioned
Hello,
the
sir.
name.
Name of ICl3 you asking, na?
Yeah, you said something.
It is an interhalogen compound.
Interhalogen.
This is interhalogen compound. Interhalogen compound, that means halogen, they react with each other to form a compound that is called interhalogen compound.
Okay.
So one more doubt. You mentioned something about being more electronegative than oxygen. How does that affect the atom which will form a negative ion?
See, when two atoms are combined, when you are calculating oxidation number and when two atoms like are there in the compound, usually the atom which is more electronegative, that is in the negative oxidation state. In
Okay,
the
more
other,
electronegative means it will become a negative ion.
no, see, if the compound is covalent, we will not talk about ions. We will talk about
No, but
ions
if it's
only
ionic.
if the compound is ionic. In a covalent compound, it's not ions. It does not get split like ionic compound. Let me give you one example to understand this. You know CH4. What is CH4?
Methane.
CH4 is a methane.
Methane.
Now, if I calculate carbon in the methane, I need to apply the rule of hydrogen. So, carbon plus 4 hydrogen, that is 0. Now, hydrogen common oxidation state is +1. Hydrogen I am taking +1 because carbon is more electronegative than hydrogen. So, carbon plus 4.
Sir,
Yes. And the hydrogen is
us,
the
sir,
yes.
we have another class, so can we leave?
All right. Just let me finish this topic only.
Okay, sir.
So, you know the exception for hydrogen. Hydrogen is found -1 only in the hydride, right? Otherwise, hydrogen is +1. So, in this case, what is the carbon? The carbon is -4. What is the oxidation number of carbon? -4. Now, same carbon when combined with the chlorine, when it forms CCl4, calculate C plus 4Cl, that is 0. So, C plus 4 -1, 0. The same carbon will come in the +4 state. So you understand it depends on the combining atom.
But sir, how do we
Okay.
know which is more negative?
Electronegative.
Okay.
Electronegative.
See, exactly the comparison you will come to know if you see the trend in a periodic table, as you go left to right in a periodic table, electronegativity increases. Point number 1. You can note it down. As you go top to bottom in the group, electronegativity decreases. In a group, electronegativity decreases. Across a period, electronegativity increases.
In a group, what happens?
Electronegativity
Decreases.
It
In a-
decreases.
in the period, electronegativity increases. Non-metals are usually more electronegative than metals, which belong to right part of the periodic table. Non-metals, they belong to right part of the periodic table.
Okay.
So
In a group, when going down, electromagnetivity decreases.
electronegativity decreases.
Going down.
Going down. When you are moving down in
Okay.
the group, electronegativity decreases. That is the reason fluorine electronegativity is more than like chlorine, bromine, and iodine. As you go from fluorine to iodine, it decreases.
So why is that? Why is that? Why does that happen? Why does the electronegativity
Okay, fine. See,
increase?
Because electrons are easier to give away when they are further away from the nucleus.
This is why fluorine is the most reactive.
Yeah.
So, see, I will discuss this topic in detail when we'll start with the periodic table. Don't worry about this.
Okay, sir. Thank you.
When we'll do periodic table, I will explain in detail. It depends on the nuclear force. It depends on the size of atom.
क्या?
I hope you have written all the rules to find oxidation number, to calculate oxidation number. You will go through these
Yes.
rules. Next time when we will meet, the session will get over after 5-10 minutes. So next time I will give you the compound, and in the compound we will find oxidation number of all the atoms in a different compound. applying this rule. As I said,
Okay.
the important rules which you are going to apply is the rule of alkali metal. Always
अरे
plus
book
1.
लिखे
Alkaline earth metal.
क्या ते
Always
table is
plus
पड़ी
2.
है
Right? Chlorine. Always
binder
minus 1.
वाली
Halogen
binder
mostly
वाली
minus 1. And the oxygen is minus 2 in most of the case. So we are going to use the rule of hydrogen, oxygen, halogen to find the oxidation number of other atoms, other combining atoms.
Okay, can we leave for CS?
So
Yes.
can we leave for C?
Yes. You can leave for the CS.
Okay.
Thank you,
Thank
sir.
you.
Thank you, sir.
Thank you, sir. Bye, sir.